Hello. Today we are going to talk about function tables and how they relate to graphs. There's three examples we're going to look at, but the first example is when you are given a function table, a table that will have your inputs and your outputs, your x's and y's, and how to convert this function table into a graph. Well, the first thing you need to do, step number one, is to create or change the function table into ordered pairs. So if you look at this function table, for example, there's four sets of inputs and its matching output, which means there's four sets of ordered pairs. The first set of ordered pair appears to be 0 and 4. So when x is 0, y, or the output, is 4. The second, 2, 8. The third set of ordered pairs, 3, 10. And then the last set of ordered pairs is 4, 12. So from reading our function table, we have our four sets of ordered pairs. Now, step two is to simply graph the ordered pairs. So the first ordered pair is 0, 4. I'll begin at my origin. X is 0, y is 4. The next is 2, 8. So at the origin, come over 2, positive 2 on the x-axis, positive 8 on the y-axis. The last is 3, 10. So I'll come over to 3, and then I'll scroll up to the 10 and put my point. Now, at this point, I could graph the remaining ordered pair of 4, 12, but considering that I don't have much room available to do so, I'm just going to go ahead and connect the points that I did make. If done correctly, I should have a straight line on my graph, and it appears as if I do. So what I have done is just converted our function table into a graph. All right? So that's the first example. The next example is when you are given a function table with missing inputs and outputs. You can use a graph to find those missing inputs and outputs by simply creating the ordered pairs in the function table, the ordered pairs that were provided to us, and graphing those. So the first ordered pair that was provided to us in the first function table was 1, 5. So when the input is 1, the output was 5. So I'm going to come over here and graph 1, 5. The next ordered pair given to us appears to be 2, 8. So I'm going to graph that, come over 2, and up 8. Now I have all the information I need to go ahead and graph my line. Remember, you want to connect the dots in a straight line if done correctly. Now that I have my straight line, I can easily go back and look at the missing inputs and outputs and read my graph to find the matching input or output. For example, starting at the bottom, we have an output or input rather of 0, but we need to find the output or the y. So if I look at my graph, what I'm looking for is when x is 0, where are we at on the coordinate plane? So remember, if x is 0, you don't go left or right. However, if we scroll up, we see that the line crosses at a positive 2. So when x is 0, in order to hit this graph, y must be a positive 2. So positive 2 is our missing output. Also, it can be done backwards. If given the output, we can find the missing input. If we look at our graph, when y is 11, which is kind of off of the chart, so we're just going to estimate about right here. When y is 11, it looks like the point would be located here on our graph, and if we scroll down, when y is 11, x appears to be 3. So when we have our output of 11 in our chart or table, the missing input was 3. The last example I want to talk to you about is when you are given a graph and you have to find all of the function table, meaning there's no x's given, there's no y givens. You're just going to look at your graph and pull out that information. Well, the first thing you're going to do, obviously, is set up or prepare for your function table by creating a column for your inputs and a column for your outputs. Then we're going to read the graph, but when we're reading the graph, remember we're looking for ordered pairs. Ordered pairs is where the points come from on our line. So for this first point, when x is 2, y appears to be a 1. So our first ordered pair, or input and output pair, when x is 2, y was 1. Next point is located obviously here, so we're going to start at the origin. To get to that point, you must come forward 4 places and up 2 places. Therefore, when your input is 4, your output is 2. Next, starting at the origin, to get to the third point, we'll go forward 6 places and up 3 places. So here, when x, or the input, is 6, y was 3. And then lastly, the fourth final point, start at the origin, you'll go forward 8 places, you'll go up 4 places, making your ordered pair 8, 4.